Good afternoon, ladies and gentlemen. I hope you're doing well. I'm very happy to be with you again. Before watching this video, don't forget to subscribe in our channel and to like the content of this presentation. In this video, I will present my new book of my bookstore of physics entitled Classical and Quantum Field Theory of Exactly Soluble Nonlinear Systems, written by Piotr Garbaczewski. This is very interesting books in quantum field theory. Classical and quantum field theory of exactly soluble nonlinear systems, written by Piotr Garbaczewski, Institute of Theoretical Physics, University of Wroclow, Poland. World Scientific, Singapore and Philadelphia. If to go through our standard field theory textbooks, both classical and quantum, on one encounter almost complete lack to exactly soluble examples, as well as almost no reference to field theories on a lattice, except for adopting some regularization of otherwise divergent expression. On the other hand, problem of strict solubility, as opposite to what we mean as exact, are the subjects of mathematical physics treatises, which are hardly accessible for not mathematically oriented readers. Our main aim is to present a variety of soluble classical and quantum field theory models from a unified perspective. When we deal with any model, we attempt at investigating its properties, but quantum mechanical and classical, and if it is possible, but on lattice and continuum. We study the relations between different versions of each model, with a special emphasis on the classical quantum relationship. One of the peculiarities of modern field theory is that, mostly because of the problems with the fermions, quantum field theory is developed as a self-contained research domain, and usually one tries to avoid any reference to the classical field theory and its relationship to the quantum one. The community of quantum field theorists does not seem to be eager to accept the statement that no quantum field theory model is satisfactorily defined unless in passage to its soluble classical partner is established. This contents of this monography. Motivation, Chapter 1, Nonlinear Problems in 1+1 their linearizations. Chapter 2, Classical Field Theory Models, Hamiltonian Formulation, Action Angle Variables Solitons, Korteweg-de Vries Field, Nonlinear Schrödinger Field, Sine-Gordon Field, Massive Turing Field, and Gross-Neveu Family. Chapter 3, Classical Lattice Models and lattice approximates of classical field. To the chain completely integrable lattice models on overview, no integrable lattice approximations of crystallizable fields. Chapter 4 Quantization on a lattice relationship classical quantum, coherent states and the three approximation concepts of both systems, quantized spin lattice systems and coherent Bose domains, lattice fermions on coherent Bose domains. Chapter 5 Quantization on a lattice simple Bose models. 5.1 Harmonically coupled chain. 5.2 Completely integrable lattice models on overview. 5.2.1 General structure of the method. 5.2 Lattice nonlinear Schrödinger model. 5.3 Lattice Sine-Gordon model. And 5.2.4 Bose quantized lattice massive Turing model. Chapter 6 Half-spin lattice systems related to nonlinear Bose problems, lattice fermions. Weakly coupled Bose systems on a lattice. Two-level half-spin approximation concepts. The ICE 6-vertex model and its bet and that's solution. Half-spin lattice versus Bose lattice, study of equivalences. 6.3.1 Isotropic half-spin Heisenberg model versus lattice nonlinear Schrödinger model. ICE model versus lattice Sine-Gordon model. Half-spin X, Y, Z Heisenberg model versus Sine-Gordon model. Half-spin lattice as lattice fermion systems. Chapter 7 Quantization in continuum joint Bose-Fermi spectral problem in 1+1. Mathematics of bosonizations. Nonlinear Schrödinger type field with the non-local harmonic coupling. Nonlinear Schrödinger field repulsive case. Massive Turing field. Curl invariant Gross-Neveu field. Chapter 8 Quantum meaning of classical field theory for Fermi systems, on the relevance of the classical solutions of the nonlinear wave equation corresponding to fermion in quantum field theory, the Fermi oscillator problem, commuting C number path integral in formulation for simple Fermi field, classical versus Fermi quantized problems. Chapter 9 Infinite constituent elementary systems canonical constitute quantization of soliton fields, free field reconstruction of interacting field and the problem of the classical quantum relationship. 9.1.1 Solitons as classical images of quantum condensates. 9.1.2 5.4.2 model. 9.1.3 Sine-Gordon model. Remarks of the massive Turing model and its free field reconstruction. 9.2 Free field constituents of Sine-Gordon solitons, quantization, confinement, and all that. Elementary two-level systems and their interaction in 1+1 dimension. The solitons is a quasi-particle to describe the propagation, the signal propagation in nonlinear medium and non-dispersive. Chapter 9, the last chapter of this book, towards 1+3 problems and prospects. Classical nonlinear field in 1+3 accounts non-spinor models. Classical nonlinear fields in 1+3 spinor models. Bose transcription of Fermi fields of the link between classical and quantum realities. Bosonization in 1+3. bosonization in the perturbative framework, fermions versus bosons, bosons versus fermions. It is there a fundamentally problem. It is 214 page book, has 10 chapters and 31 paragraphs. This is some contents of this monography. It is very important and very crucial monography in quantum field theory in relation with the particle physics, nuclear physics, collective model of nucleus, theory of condensate matter physics, also superconductivity, superfluidity in reports between the liquid the quantum liquids and the collective phenomena. So the quantum field theory play a very important role in quantum field mechanics or elementary interaction and quantization of elementary interaction like quantum chromodynamics, electroweak theory, supersymmetry theory, Richen's theory, and Bryan's theory, grand unification theory, also in condensate matter physics, like superconductivity, quantum liquids, like for helium, quantum liquids, polaritonics and excitonics, quantum field in quantum liquids in semiconductor low temperature, collective phenomena in plasmas, and biology, application of quantum field theory in biology, in cold nuclear fusion theory. Some example for application of this theory in biology and biochemistry and biophysics. This is the conformance or the configurance. This is one quasi-particles for quantization, breaking chemical bonds and conformal transitions in biological macromolecules like proteins, nucleic acids, etc. And explaining of photosynthesis, respiratory chain, and photochemistry of vision, stability of DNA and RNA, degeneracy of genetic code, application of Davidov solitons in explaining of muscular contraction and interaction between actin myosin complex, application of this theory for describing of interaction hormone receptor, propagation of nervous influx, interaction between enzyme substrates, and stability of microtubules and microfilaments of cellular skeleton cells. The configurants, this is the quasi-particles can explaining the chemical reactivity and propagation of electrochemical oscillation in electrochemical reaction. Okay, the quantum field theory is very rich and very important theory by these applications in multi and different domains of knowledge, of scientific knowledge, biology, biochemistry, biophysics, elementary particle physics, nuclear and atomic physics, chemistry, electrochemistry, quantum theory, etc. This is very interesting book. Some contents of this monography. We are coming to end of this masterpiece. Thank you for your attention. Don't forget again to like our contents and subscribe in our channel. Thank you very much.